Welcome to this lesson on specific heat capacity, part of our thermodynamics series. Today, we'll explore how different materials store thermal energy and why some substances heat up faster than others. Specific heat capacity is defined as the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius, or equivalently, 1 Kelvin. In simpler terms, it measures how well a material can store thermal energy. Materials with high specific heat capacity can absorb a lot of heat before their temperature rises significantly. The formula for calculating heat energy is Q equals m times C times delta T here. Q represents the heat energy in joules, m is the mass in kilograms, C is the specific heat capacity, and delta T is the change in temperature. The SI unit for specific heat capacity is joules per kilogram per degree Celsius, which can also be expressed as joules per kilogram per Kelvin, since a change of 1 degree Celsius equals a change of 1 Kelvin. Let's understand what high and low specific heat capacity means. A material with high specific heat capacity needs more energy to change its temperature, which means it heats up slowly and also cools down slowly. On the other hand, a material with low specific heat capacity needs less energy to change temperature, so it heats up quickly and cools down quickly as well. This property is crucial in determining how materials behave when exposed to heat. Different materials have vastly different specific heat capacities. Water has one of the highest values at 4,186 joules per kilogram per degree Celsius. Ice has 2,090 joules per kilogram per degree Celsius, and concrete has 880 joules per kilogram per degree Celsius. In contrast, metals typically have lower values. Aluminum has 900, iron has 450, and copper has 385 joules per kilogram per degree Celsius. This explains why metal objects heat up much faster than water when exposed to the same heat source. Specific heat capacity has important real-world applications. In coastal climates, water's high specific heat helps moderate ocean temperatures, keeping coastal areas cooler in summer and warmer in winter. Car radiators use water as a coolant because it can absorb large amounts of engine heat effectively. Cooking utensils are made from metals because their low specific heat allows them to heat up quickly for efficient cooking. Building materials like concrete are chosen for their ability to store heat during the day and release it slowly at night, helping regulate indoor temperatures. Let's work through a sample calculation. How much heat is needed to raise the temperature of 2 kilograms of water from 20 degrees Celsius to 80 degrees Celsius? We are given mass equals 2 kilograms, specific heat capacity of water equals 4,186 joules per kilogram per degree Celsius, and the temperature change delta T equals 80 minus 20, which is 60 degrees Celsius. Using the formula Q equals m times C times delta T, we get Q equals 2 times 4,186 times 60, which equals 502,320 joules. This is the amount of energy required. Let's review the key takeaways from this lesson. First, specific heat capacity measures the energy needed to change the temperature of a material. Second, water has one of the highest specific heat values, making it an excellent thermal regulator. Third, metals typically have low specific heat capacity, which is why they heat up and cool down rapidly. Finally, materials with high specific heat experience slower temperature changes compared to those with low specific heat. Understanding these concepts helps us explain many everyday phenomena and make informed decisions about material selection in engineering and design.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.